At Uber and formerly at Apple, and today I'm here to tell you why you suck at coding interviews. Next slide. So let me go through a little bit of what this talk is going to entail. I'm going to spend the first 8 to 10 minutes talking about my background and philosophy of engineering, and that will lead into the 9 most common mistakes I see in interviews. Now, anyone is going to make any number of, let's say, one of 10,000 different mistakes in an interview, but I roughly categorize it into these 9. Why? Well, a lot of them I'm going to give you the background for before I dive into what those mistakes are, why these are important, what mistakes are you making, and how you can possibly fix them. And by the end of this talk, I'm hoping to convince you of 2 points. The first is that the interview and your career are not separate entities. What you do in one, you'll do in the other. And the interview is therefore a decent reflection of how you act as an engineer on the job. Contrarian, yes, I know, but bear with me for the next 40 minutes. The second point I want to make is that you really should not rely on luck for these coding interviews. Given the current macroeconomic environment we're in, where there aren't a lot of job openings, you really need to make sure that every single interview that you get, you get the offer for. So don't rely on luck. Make sure you get good. And that's not a real get command, by the way, but just keep that in mind. We'll reserve the last 10 to 15 minutes for Q&A, and hopefully I'll be able to show you videos of my cats. So, few bookkeeping disclaimers. Currently, I work at Uber, and before that, I was at Apple. None of the opinions here express any of the opinions of my current or past employer. I also run a business coaching people for coding interviews, but the model is very different from Taro's, and in fact, I think complements Taro in some way, which is why I've agreed to give this talk. So let me get the answer to the title right now. Let's get out of the way. Engineering is more than just coding. And what does this mean? I want to preface this with a story, or rather a personal failing. Back when I was at Apple, I introduced a line of code that would read a hash map while modifying it. And for those of you out there who are very familiar with Java, you'll recognize this as the cause of the concurrent modification exception. So when the server decided to flip a bit and change the payload that they were sending down, my line caused every single app in the world to break, and we had to quickly revert it. So yes, I was responsible for a really bad outage. In the postmortem, when we were trying to figure out what was going on, my tech lead took me aside and imparted upon me this piece of wisdom. Engineering is more than just coding. But what exactly does this mean? This just means that you should understand what you're building, why you're building it, why your solution that you're building is the best of all possible solutions, where will it kill us, and how can you prevent it from killing us? Most people only focus on writing what and how to write it and then just ship it. But there's a lot bigger dimension to this than you might think. And so these are the top 9 interviewing mistakes that I see. I won't read them out, but I want you to notice that all of these have to do with execution of information, not information itself. Yes, there are times when people don't know what dynamic programming is, or don't know recursion, or don't know what a load balancer is. Maybe they aren't really clear on sharding algorithms either. But almost always, the failure is in the execution of that knowledge, not in whether or not you have it. And I'm going to roughly go over each one of these points later, but I want you to consider for a brief moment why I may have chosen these top 9 mistakes that I did. So let's kind of backtrack a little bit. Let's actually prove why it's important to focus on execution. Your typical interview is going to consist of 3 parts. The first one is your data structure and algorithms portion, which is your standard lead code style interview. You're given a toy problem or two, and you have to solve it in 45 minutes. The second is the system design, where you're going to be building, let's say, a website like Twitter or Facebook, a smaller version of that, and maybe even one small portion of that product itself. So maybe like the news feed. And then the last part is the behavioral interview, where you're going to talk with a engineer or your interviewer about your work history, and they'll field you like the typical behavioral questions. So when I was trying to actually do well at these interviews back in 2016 and 2019, I was looking online for a lot of advice, right? And most of the advice you'll probably see boiled down to these 4 points. Just make sure you communicate. It's just a numbers game, spam leak code, and you're never going to really use the algorithms in real life. But what I found, the reason why this is bad advice is because I really couldn't distinguish the people telling me the advice from people who are lucky, from people who are skillful. In fact, this advice, I would argue, is actually worse than no information, because you have to consider that for every piece of advice and information that you act on, how many times would it have helped you versus how many times would it have killed you? A good analogy would be if I'm playing a game of Russian roulette and you tell me a winning strategy is to load an extra bullet in the chamber. Obviously that's going to hurt my chances. But if I win that Russian roulette game, you might come up to me and say, hey, my strategy helped you. No, I won in spite of that strategy. And so, roughly translated, you can kind of see where this becomes bad advice. So, for instance, saying that it's a numbers game just means that you're going to pay more attention at getting more coding interviews rather than doing well at these interviews. So, it actually decreases your efficacy of how you will actually perform. And to illustrate this point and drive it home, this is a chart of the number of job openings that occurred in 2022. Now you can see at the beginning of the year, everyone's hiring, everyone's happy, job offers around, there are really high salaries, et cetera, et cetera. But of course, as you know, hiring freezes and layoffs made getting jobs extremely difficult. So over the course of 12 to 18 months, we went down about 50 to 60% in job openings, and that has not since recovered. So that, going back to the previous piece of advice, is just a numbers game. Well, what happens when the numbers dry up? Well, at that point, you're at the whims of the macroeconomic cycle, which is as fickle as the winds. So that is a very fragile and borderline useless piece of advice, because it means it goes out the window the moment something outside of your control, outside of the interview happens. So I'm not sure you want Jerome Powell to be deciding the fate of your job offer. That's not a winning strategy in my view. And so I decided to go out and systematize my method of thinking, focusing on execution, focusing on consistency and delivering. And these are the numbers that I came up with after 3 years of doing this. I myself have a personal 80% success rate. I think the only interviews I've failed were the first time at Google and Amazon. I think it was Amazon as well. I can't remember that. But I was also able to replicate this rate of success in my clients where they've had a 70% success rate. And that motivated me to write the document, Welcome to the Coding Interview, You Suck. And that has been pretty well received. I think it's gone through one revision since, but the main fundamental ideas still hold. And to drive home the point of consistency of execution, in 2022, we were still able to get 40% of our interviews a job offer. So that's well above, I think, the industry average. The best performance we ever had was a staff offer that was the #2 highest offer given for Wayfair in Germany. So the highest according to levels.fyi in dollar amount. So who am I? Let's look at my professional experience out of the way. I am an Android engineer. The only real programming language I know is Java. I barely know Kotlin at this point, and I can kind of do okay at Python, but I'm using Java most of the time, which is arguably the worst programming language to use for coding interviews. In 2016, straight out of college, I joined Apple. Yes, we have an Apple Music for Android app. It's a fantastic. Please check it out if you have an Android phone. And in 2020, I joined Uber. And I remember this quite well because I joined Uber in April. And 2 weeks later, they decided to lay off 25% of the company. And I was very scared. I was wondering if I still had a job after all that. So I fortunately survived. And today I'm working on Android infrastructure with a fantastic team full of really smart people, helping to migrate our code base from Buck to Bazel. And so let me wrap all this intro up with the thesis, the engineering process. What I think the misconception in the industry is that there's too much focus on coding and information. If you take the job title of software engineer, well, coding and information is just the software portion of it, but you've completely missed out on the engineering portion. How efficient are you at producing value? So if you consider the engineering process, you have to scope out a problem, define it, create a prototype, test it, improve it, and so on and so forth. You're going to be going through this cycle over and over again. And as you progress through your career and you get better at engineering, the question is, how quickly can you go through this? Can you skip some cycles simply by just thinking about the problem in new and different ways? And modern software has become actually significantly more complex at big tech companies. Everyone can write simple little mobile apps via tutorials. All knowns are really known, and most of the information advantage is gone. What you're really going to be doing in the real world is you're going to be managing more and more complexity at bigger and bigger scale with less and less information. So you're not going to always know everything. In fact, it's going to be up to you to figure out what the information you need to know is, and how do you know you have enough information to start acting on it. So how you do something is going to be worth way more than what you know. So hopefully I've kind of proven to you that at least in some dimensions of engineering and coding, you're going to need to focus way more on execution. But then some of you out there in the crowd might say, hey, wait a minute, I'm not convinced at all that interviews and my career are exactly the same. I've been told my entire life that I just need to grind 600 leak code problems and just focus on interviews exclusively, and that it has no bearing on what my career might have. And so hopefully by looking at each one of these 9 mistakes that are prevalent in both the interview and the career, I'm going to show you that the way to solve them in your interview and career are exactly the same. And so let's get to the first mistake, not putting in enough time. What I found my clients is that the bare minimum amount of time we need in order to get them interview ready and hit that 70% hit rate is 2 to 3 hours a day of studying for 3 months. If they were mediocre and just kind of didn't do what I asked them to do, it would take them 6 months. But if they were doing it badly and just spammed, leak code, they would never get there. And you frequently see this on leak code forums where people say they have done 600 problems and have gotten nowhere. It's almost always because they're just trying to solve problems and move on, but they're not trying to put in enough time or effort. But let's just focus on one thing at a time. By not putting in enough time, I always ask people if they're putting at least 20 hours a week for preparing for interviews. Not only that, they need to be disciplined and consistent about putting the time in. What most people end up doing is just saying they'll randomly put in an hour here, an hour there, and maybe 3 hours on Wednesday, but then cancel because one of their friends is having dinner and so on and so forth. And then at the end, they hope that it adds up to the 20-hour benchmark. And that's not what you're trying to do. I think that most people should actually keep a very rigorous and disciplined schedule. Make sure that you allocate an hour and a half to studying, then take a break, then go back to studying. Keep that schedule consistent every day. And in your career, you should consider that everyone else is putting in 40 hours a week to try and advance in their career. If you're expecting to get promoted faster and more frequent, I would say at a better rate than other people, you have only 2 options, right? The first is to be smarter than everyone else. And everyone at big tech companies is really, really smart. I can say that as like safely my team is full of some of the most brilliant engineers I have ever had the pleasure of meeting. The other thing is that you're going to need to put in more time. That's your only other option. And so being consistent about the time you put in at work, you need to be able to track that and dedicate yourself to that if you're going to be if you want to get the career promotions faster than anyone else. In fact, when I was at Apple, my first 3 to 4 years of my career, I was putting in 12 hours a day, 5 days a week, constantly just rereading my own code, reading the code of the code base, looking at what all my other coworkers were doing and copying them. The second mistake I see people make is that their interview problem-solving approach is inconsistent. Again, we're going back to the idea that execution matters above everything else. There's a few ways you can kind of prove this. The first is that humans are creatures of habit, and what motivates you in one area of life is going to bleed through in another area. You don't just really end up being hardworking at your career, but very lazy when it comes to your personal life. Very, very few people are actually like that. Most people are pretty consistent. And so your inconsistent approach will lead to inconsistent results, which makes sense. What you do in practicing for your coding interviews is going to be what you do on game day. There's no such thing as I'll just do it when it counts. And it's illustrated by this really simple mantra that I really like. Rules create discipline. Discipline creates consistency. Consistency creates habits, and habits create results. That's pretty logical, right? But maybe you don't buy the human psychology argument? Well, let's look at it from a more pragmatic and practical sense. The industry has gotten smarter. What do I mean by industry? Well, the companies that are hiring engineers, they've kind of figured out, like I would say probably 5 years ago, that memorizing questions, people were just memorizing questions, and then they would just give them a golden green check mark if they got the right answer. And so this ended up really not allowing us to hire the best engineers. In fact, it actually only allowed us to hire people who were gaming the system. And so the industry has gone on to revamp the way they examine engineers and the way they conduct these coding interviews, where there's much less emphasis on knowledge, much less emphasis on, your textbook algorithms, and much more emphasis on just being able to execute on simple toy problems. And this has been confirmed by my conversations with people from Meta, from Google, and also by the questions that I've seen my clients get asked at these coding interviews. And so I'm going to ask you, do you have a checklist or framework for approaching problems? Are you able to constantly revise that and make it more consistent after every single problem that you do? In your career, you're pretty much evaluated on exactly the same thing. You're evaluated on your ability to deliver quality work consistently. So it's not just that you can ship code, willy-nilly. Some projects you'll do well on, some projects you'll fail. No, you're evaluated based on your ability to consistently deliver at the scope that you need to. And so having that checklist actually helps quite a bit. And so this is where I'm going to give you a little peek into how I've managed my own career. This engineering checklist, and I'm sure Raul will send you the link to this. This is the checklist that I personally use when I go through any particular problem in my career. You'll see here a snapshot from that checklist, and it'll be me trying to solve the problem. And the reason this checklist exists is to keep my thinking consistent. It forces me to avoid bad or inefficient work. And each one of these questions that I ask myself is born from a particular failing that I've had, whether I broke something in production, whether it got sent back for review or the design was rejected multiple times. Anything that that I thought was inefficient, I try to capture that in a question. And since then, this checklist has gone through multiple revisions. So there are some stories that do get lost, but almost always these should encompass any of the past mistakes or failings that I have had. One way you can tell you're doing bad or inefficient work is if you are constantly debugging. And you'll frequently see this with people who are doing LeetCode problems in their practice. I'm sure all of you are familiar with just spamming the LeetCode compiler, writing print statements, and hoping a solution falls out and then moving on. That is a sign of inefficient work, and that means that your approach can be improved. I think another way people kind of misinterpret the job as an engineer is that they think it's all about shipping code, right? Well, I would argue that if you're not spending at least half your time sitting on your butt thinking about what you're writing about or reading through existing documentation and researching, you're probably doing it wrong, because that means that you haven't spent enough time thinking about your whole solution. Why is it the best? How will it kill us? And so being able to think is an extraordinarily powerful thing to do. The third mistake that I see people make is that their practice is inconsistent. And so we're going to get into actually executing on these ideas. I always get asked whether someone should study one topic every day and that's a different topic, or they should go into one topic very, very deeply and just master that before moving on. I always say depth of understanding is worth more than breadth of understanding, not just because you'll retain it better, but also because you'll also have a much better understanding of when to use something. So saying that you'll study X today, Y tomorrow, again, goes back to the whole idea of being inconsistent is what's going to hurt your performance. And how do you know that you have mastered something? Well, not only do you have to understand what it is, but when to use it, and most importantly, when not to use it. Most people understand, hey, as long as I memorize the information, I'm good. That's the bare minimum. most people, and then a few people get to when to use a particular data structure or algorithm or particular system design component. Yeah, that's great, but the most important thing out of all of this is knowing when using that particular data structure or algorithm, that particular system design component. When will it kill you? You can't solve all your problems by throwing a hash map at it. You can't solve all your problems by throwing a load balancer at your system design. That's not how this works, because obviously, if you try forcing some functionality upon a piece of code or an algorithm, that leads to over engineering. And that has been the disaster and that's been the Achilles heel of many, many projects and code bases, because that almost always forces a rewrite, and that is time wasted. And so you need to understand what situations will X be more likely to get you the right answer. There's a really good saying that to a man with a hammer, everything looks like a nail. And if you do this, I guarantee you, you're not going to build a good house with it. In fact, you're more likely to destroy it than not, even though a hammer is a wonderful tool for building a house. So, in your own career, are you thinking about the quality and efficiency of your work? And a really good way to kind of see how companies force you into this is by putting you in one section of the code base and making you master it before you branch out into other areas. And so this is what we call being a domain expert, making sure you can consistently understand and deliver on one area of the code base. In fact, another way you can invert the problem and think about what happens when someone jumps from code area to code area. If you ask this person, hey, how does feature X work? And the person just shrugs his shoulders and says, I don't know, I only worked on it for 3 months. You're going to look at him a little funny. Like, what have you been doing this entire time? How do you even know that the code that you shipped in that area even works? If you can't tell me, at least on a basic level, how that code works. And so being able to be a subject matter domain expert on one thing before you go to the next is critically important. The fourth mistake that people make is not fixing their own mistakes. This was kind of an obvious duh, but when you think about it, but you'll be surprised how many people just kind of make the mistake and then move on without reflecting on it. The other side of the coin is that people kind of take it too far and beat themselves up over their mistakes. It's okay to make mistakes. Everyone's going to make mistakes. I make mistakes probably more often than you think. I would say even now I've probably committed some mistake or error in the code base, but that's besides the point. It's okay to make mistakes, but it's not okay to repeat them. If you find yourself repeating them, that means that you haven't solved them, and you're more likely to repeat the mistake going on in the future. Now, what kind of mistakes should you be focusing on? You should be focusing on mistakes that have to do with the application of knowledge, your approach, and execution of the idea, not necessarily the knowledge itself. There's always going to be missing gaps in knowledge. In complex code bases, the information under your feet is shifting constantly every day as people land more and more commits. Documentation gets outdated, and some people leave the team, so you lose that context and domain knowledge. So again, you're constantly working on imperfect information, and that really cannot be avoided. The best you can do is gather as much information as you can that you think is relevant and find the appropriate way to execute on it. There's no such thing as, I'll just do it when it counts, or I'll do it next time. I always ask people if they are tracking their mistakes and inefficiencies, if they are holding themselves accountable for the mistakes that they make, and whether or not they have a practice diary, whether or not they're recording the problems that they're doing, what happened during the problem, and how they can do better. In your career, you can think of the postmortem process as exactly that. So what is the postmortem process? Whenever an outage occurs or some bad code lands, the company will do an audit from A to Z, trying to figure out how this was allowed to happen. They'll go back through the 5 whys and get to the root cause and address every single point along the way. And in doing so, they make their systems more robust, whether that is adding more testing, whether that's changing their processes for evaluating how code is landed, and so on and so forth. And so you should be doing exactly that. You can't always rely on systems and the interviewer to catch your mistake. Some people kind of over rely on interviewers in the coding interview. Other people rely on the CI/CD testing system to catch all their mistakes. And I'll tell you, as someone who helps to manage the CI/CD system, that people who do this consistently cause us to violate our land time SLOs. And that is a very bad thing. You do not want to jam up the entire company just because you're hammering the infrastructure with diffs and hoping that the infrastructure will catch it for you. So do you apply the post-mortem process to yourself, even if it is a small inefficiency? Excuse me. And so this is a sample diary entry that I make all my clients have. You can see here that it records the problem that is done, the level of difficulty that they thought it was, how long they spent on it. And on the right-hand side, you can see that they take pretty detailed notes on what they're doing at what particular point in time. Now, why do we do this? How are we able to do it? The reason why we do this is so that way we can see what steps are being taken and how much time is being allocated to each step. So you can see here for the first minute, they're presenting the problem. And then from 1 minute to 2 minutes, they have a naive approach. Then they go on talking about the inefficiencies, discussing how it could be better, acknowledging trade-offs, tracing plan for an algorithm, and so on and so forth. And this gives us a clue when we look back at the problem as to where we might be spending too much time, not enough time. Maybe the approach is wrong if we see that it occurs consistently throughout multiple problems in which they fail to get the right solution. You can also see that he tries to figure out if he got the right solution or not and why. And so what I do for my clients is that I make them record themselves doing the problem, talking out the problem, and putting pen to paper and really tracking their thought process along the way. That way, when we review the replay, I can ask them, why did you decide to do, testing at this particular point? Why did you go with a load balancer here? Why did you decide to use the particular sharding algorithm? And we can see the full context. We can see what information that they gathered, what information they parsed, and we can reverse engineer their decision making and decide whether it was reasonable or not. And that's where things start becoming a little bit less deterministic, that it requires a level of intuition and human judgment to evaluate whether or not a particular process was good or not. But you can't even have that discussion until you actually write down every single one of your mistakes and what you are doing. You can even see at the end, he compares himself to the book answer and says, hey, he himself is less efficient, less clean than the book. And so we'll talk a little bit more about what it takes to improve your mistakes, but hopefully this gives you an idea of the level of detail it takes to improve upon your problem-solving approach. In your career, you'll also find that this happens, that you're going to need to constantly fix your own mistakes. And what I find is that more often than not, this boils down to, I would say, 3 to 4 factors that are responsible for 60 to 70% of the mistakes that you consistently make. And so some of these might be technical knowledge, others might be psychological tics. And I'll present one of my own failings and hopefully that will give color to this particular point. My particular flaw is that I always rush to ship code. After I have done all the testing, the scoping, the planning, gone through weeks of just iterating and improving the idea and code, I have this bad propensity of asking people really, really quickly, hey, can you look at my diff and stamp it? And this leads to a 24-hour cycle time where I'm stuck in limbo doing nothing. And what I found is that if I had just simply stopped my work for the day, gone home, taken a nap, and then spent 5 minutes the next morning reviewing it, I could avoid a lot of the silly mistakes that would have been caught by my reviewer, whether those are small nits like code formatting, improper imports, maybe the design seems a little bit redundant and could have been caught if I just scrolled up, a few clicks on my wheel and just looked at the top of the file. Small, really, really weird things that just happen. And at first I thought these were all separate mistakes, but it took me 5 years for me to figure out it's because I'm rushing to ship code. And so that's why I have this rule here. Wait 24 hours after coming up with a solution to ask for a review. This saves me at least like a good 20 to 30% of the mistakes that I make. So the only way you really get here is if you assume you are the reason for your own failure, no matter if that failure is big or small. You need to find out why you make certain mistakes and try not to make them again. And again, you can kind of see how this plays into the coding interview as well. You might think that, oh, maybe I'm not spending enough time on testing, and therefore I consistently keep missing code coverage and mistake and different use cases at the end, which causes my code to fail. If you start looking for the common points of failure in all your problem solving or any points of inefficiency, you're more likely to get the right result. And better yet, the solution to it is way more simple than you think. The fifth mistake that most people make, I think, is not seeing how one decision leads to another. I think most people kind of assume that things are deterministic and very stable and predictable. But again, in complex adaptive systems, you can never really do just one thing. Even if you ship some very simple piece of code in a complex code base, the cascading effects that it causes can never be really predicted. And therefore, you should really have an appreciation for how one change can affect the next thing and the next thing and the next thing. Taken to your own process for how you do the coding interview, you understanding design and code, how one feeds into another. Once you understand the problem, you can design it. Once you can design the solution, you can then code it up. But not having an appreciation for how a failure to understand can lead to bad design and code is a very big mistake. Most people just look at the end result, just look at the code and just say, oh, I could have coded better, whatever. No, no, no. You need to go back up through the decision tree. Look back at every single step, especially at the beginning. If you want to understand why chess games, occur the way they do, you want to study openings and you want to study endings. The mid game is up to the player, but almost always the biggest faults can be found in the very beginning. And so I really recommend, if you find yourself consistently being unable to come up with good system designs or good code, then look to see if you've properly understood the problem. Why did you make the mistakes that you did? And having an appreciation that because of X, you did Y. Well, I want to expand a little bit more on this. This might be a novel idea to you, but the idea, think of it like a hand of poker. There are things that you can do that can increase your odds of success or decrease your odds of success. Whether or not you decide to add more chips to the pool, whether or not you want to flip over the next card, or maybe you want to bluff your opponent out. There are certain things that you can do to try and improve your odds of getting to the right answer. And you should think of the coding interview as exactly that. Another point you want to consider is that multiple factors will lead you to the choices that you do. It's never just one piece of misunderstanding. It's usually a piece of understanding, your practice, and maybe your underlying beliefs of how code should be written or designed, or maybe how systems should be designed. Multiple factors often lead you to the choices that you do. So really consider what factors have pushed you to making the bad decisions that you have, and start eliminating each one of those factors. Again, going back to the poker analogy, you're trying to tilt the hands and odds in your favor by having different systems and different questions that you ask yourself to avoid failure. And so, are you thinking about the factors that will lead you to your answer? What controls do you have that allow you to progress through the problem and avoid those failures? The sixth mistake I see people make is that, oh, actually, I'm going to go back to the slide. I realized there's one other point I want to talk about. There are a few things that you can actually do in the coding interview as well. You can test the idea or design. You can come up with good test cases, making sure that the design is simple, making sure that the test cases are simple and comprehensive. I sometimes see people just constantly keep testing and testing and testing out of paranoia, even though the additional test cases don't actually add to any additional benefit. Worse, they actually waste time. And finally, making sure that you have complete and accurate information. How do you know you have complete and accurate information? I'll leave that to you to figure out. I think it's a very interesting question to have, especially when you're dealing with a constantly changing code base, or you're dealing with a toy problem. How do you know that you have asked enough questions? That's a very interesting question to have, actually. So the sixth mistake is not understanding your own solution before coding. I think a lot of people really have this misconception in the industry that engineers are coming up with these brilliant, brilliant solutions that are super, super complex, Einstein level, that no one could possibly comprehend or understand or come up with. That's really not the case. What I find is that the more fancy and brilliant you try to be, the more likely that solution is misunderstood and will likely kill you. On the other hand, if you go with a very deeply simple and robust solution, there are only a few avenues which the solution will fail, and it's very obvious to most people how it will fail. Not only that, if it's very simple, you get those fast code reviews, and people will instantly give you the LGTM stamp, which is looks good to me. And this is, again, really common in the career. Deep simplicity beats everything else. If you try to be too brilliant, people are going to be, they don't know what you're talking about, because a lot of people who are reviewing your code, your design, are not going to have the same context that you have. And so therefore, you need to make it very, very easy for you to actually, I say very, very easy for other people to actually give you the looks good to me stamp and make it simple. Serve it up to them on a platter and make it easy for them to consume. Another way I heard some of my clients express this is that they have too many ideas when it comes to scoping out the interview problem, that they have too many ideas jumbled up in their head. I call this not thinking, because out of all those ideas, you need to consider which of those ideas is more likely than others to get you to the right solution. So how to avoid this? Make sure that you can explain the solution to a 5-year-old with no prior understanding of computer science or engineering. You should be able to walk through your code with pencil and paper and write it out. And this is actually what I always did when I was doing my interviews. I would do every single problem on pencil and paper. I've probably gone through a few trees doing this, but it's been very effective, because when you go to the whiteboard, you're going to be writing out with an expo marker and a board. So that's as close to pencil as paper as you're going to get. You should also be able to walk through the stack trace of your code. Once you have the code in design, you should be able to simulate what exactly the stack is going to do. If you do recursion, you should be able to simulate what that stack looks like and what the variable values are. But the best test by far is whether or not someone else with no context can understand you. So imagine you're doing the coding interview, and someone who is not related to the interview, not your interviewer, walks into the room. Can they, within 5 minutes of listening to you talk, looking at the whiteboard and just following along, can they roughly understand where you're going? If they can do this, then chances are you're on the right track and you have a deeply simple solution and a deeply simple set of steps that allow you to get you to the right solution. Remember, you don't want to lose the interviewer here. So deep, simple, clear ideas will always win and reduce cascading uncertainty. If you can communicate clear ideas, if you have clear ideas, you can communicate clearly. And so in my own career, this is what the ERD is, the engineering review document. All it is just someone writing out what they plan to do and why. Where people trip up is that they make it overly verbose. What they try to do is try to make it fancy. They try to explain every line of reasoning. And I actually had this problem for a little while because I wasn't quite sure how to organize the ERD. But what I found is that if you just moved all the discussions, the points, the counterpoints, the reasoning into footnotes and into comments on the side of the document, the mainstay of the document can easily be read. And if people want to say, hey, wait a minute, why did this person come up with this line of reasoning or this particular solution, they can click on a particular sentence and see the full discussion. More often than not, that's going to be populated by other people, but you should preempt every single possible counterpoint and counter argument that you might face. I also have this little short list. Anytime I'm about to write code, I do the short list 5-10 minute drill to make sure I really understand what exactly I'm writing. I write out what my goals are, what's out of scope, what are the alternatives, what tools I'm going to use, what exactly the codes will look like, because once you create the diff, there's no going back, and how I will test it, how I can roll it out, and what are the problems that to watch out for, otherwise known as the blast radius. And the blast radius is almost always bigger than you think. So again, this little short list is there to make sure I really understand what I am writing. The seventh mistake that I see people make is rely on magic bullets. What do I mean by magic bullets? Throw stuff against the wall and see what sticks, hoping that a random answer that you come up with will actually work and solve your problems in the coding interview. I think everyone's been guilty of this before. They think everything can be solved with a hash map or a sliding window algorithm, but there's a time and place for everything. More pragmatically, what happens when someone challenges your idea? What happens if someone says, all right, you chose to use, dynamic programming for this. Why? you're just going to be stuck there and say, I don't know, it just seems to work. That's not how it works. All it takes is just 1 to 2 test case failures or scenarios that you didn't think of to destroy your code and design. And I want to preface this with a story. In 2017, Uber was moving their iOS app from Objective-C to Swift, and this is public knowledge. And they were using a bunch of compilation hacks in the Swift compiler. And as a result, they ended up shipping a binary that was way too big, and so had to disown the Objective-C code base that they were using. In other words, they were burning their bridges and making sure that they could never go back. And they effectively called this strategy YOLO, as in you only live once. That should tell you to the degree of thinking that they were doing. They were just saying, hey, whatever, let's just go with it. And had they failed, there would have been a lot of engineering managers, engineering directors that would have had to resign because of the amount of political capital that got put in here, and not to mention the code base that got thrown out. So going for a full YOLO, relying on random stuff, is the bane of any organization and will make people sweat bullets. And another way you can think about this is there's a very big difference between what you think you know and what you can prove. Everyone thought the migration from Objective-C to Swift would have worked. Not the case. It turns out once you actually got to the finish line. Again, this is public information. There's a great Twitter thread by Stanley B. He now works at Amazon. He was on the project, and he actually wrote about this. It's a fantastic thread. I recommend you look it up and read it. So being able to justify every step in your process is going to be very, very important. Do you bulletproof your code and design, and making sure that you go through the pre-mortem, anticipating what can go wrong, the post-mortem, what happens after you've landed, what can fail, and then the possible test cases that you will come up with. The 8th mistake I see people make is not being fast enough. Yeah, okay, maybe you avoided the past 7 mistakes, and given an unlimited amount of time, you can solve any problem. But again, the interview is finite. The time you're given in the interview is finite. The amount of time you're given to solve a problem in the real world is finite. You need to be efficient. The value produced per resources consumed. If your approach is bulletproof and methodic, you should be able to solve any problem. The question now is, how quickly can you parse down the scope and eliminate the wrong areas? And therefore, your goal state here is to get to a series of automatic actions that don't require a significant amount of thinking. This is why I make all my clients write out the pattern that they know, whether it's sliding window, whether it's 2-pointer or whatnot, over and over and over again. If you should be able to do the skeleton of a binary search almost automatically. That way you don't have to think about it. But the goal is to be able to look at a problem, have 2 to 3 different ways of solving it, or at least having an idea of how to get to the optimal solution, and then just filling the blanks as you go. Oh, if we're going to go with X, if I have X piece of information, I'll go down this way. If I have Y piece of information, I'll go down the other way, and so on and so forth. You can kind of see the tree in your mind immediately. So the mistake I see people make is that they're being way too formulaic, that they're not focusing on what matters. They're focusing on just filling out a checklist, or how do I describe it? Being too pedantic, overly focused on the wrong details. Maybe overly testing is a great example, or overly checking the code. Again, if you're doing this right, the code should come out naturally, especially if you've thought of every single possible solution that can occur. And the 9th mistake, this is my absolute favorite, being full of crap. And being full of crap is a very interesting phenomenon, because a lot of people who don't know they're full of crap are full of crap. The reason why, and it boils down to this one quote: "You must not fool yourself. You are the easiest person to fool." And this is by Richard Feynman, the physicist. What people get wrong is that they think communicating more is going to help the end interviewer understand what they are talking about. And what I find is that the exact opposite is true. The more you communicate and the more information you add, the less clear you become, because you're going to be directing the person's attention in 10 different ways. And you'll lose the interviewer. You're going to lose your audience. That's not what you want to do at all. More words does not mean more information. And I'll give you a very solid example here. This is the Google annual report, the Alphabet 10K. You can see here, it's like 100 pages of nothing but legalese. Now, did it make it any more clear as to how Google operates, what they're doing, where they're spending capital? Probably not. Like, a lot of this is just legalese. I'll give you a sample example. Critical accounting estimates. We estimate our consolidated financial estimates in accordance with GAAP. In doing so, we have made estimates and assumptions. Our critical accounting estimates are those estimates that blah, blah, blah. You see, like we're like 30 words in and I have no idea what the hell they're talking about. So talking more and communicating more is almost always going to lead you to not understanding, or I should say losing your audience, even though you might think you're giving them all the information that they need to do proper due diligence and proper decision making. No, you're going to lose them. You're going to misdirect them. So get to the point and make sure you get there in an understandable way, especially in your ERDs. One good tip for this is to make sure that you can draw out exactly step by step what you're going to do. So check and ask yourself if you have a clear idea, intention behind everything you say. Really record yourself talking and ask if you say unnecessary things, making sure that your communication is inefficient. ERDs, like I mentioned before, get rejected because they are not simple. And another way you can kind of tell if someone's full of it is if they just keep rambling on and on about nothing. If you can zone out for 10 minutes, come back into the conversation, and you haven't really lost any context or information, chances are that person's full of crap. As Ben Franklin puts it, it's hard for an empty sack to sit upright. So if you find you have trouble communicating, ask yourself if you are losing your audience by saying random stuff. And I'm going to kind of breeze through the last few slides since I'm running out of time. Make sure that whenever you do an ERD, make sure that you cite data, existing documentations, and use very simple language. And make sure that you back up everything you say, you back up with a source or a particular discussion that you had with another engineer. So I want to give you something that you can take away from this talk with. You know, enough of me like telling you what your mistakes are. I'm going to give you something that you can actually take home today and start using. This is a very basic approach to how you can do well at the coding interviews. All this really is just a derivative of the engineering process. Start with a simple problem. Start with a simple like a solution. And if you can't come up with a simple solution, just throw random crap until you get a pattern and then try to make an algorithm from that. Identify the shortcomings of the algorithm, where it is inefficient, where it might be messy, and for each inefficiency, how can you fix it? And once you identify all these different inefficiencies, you'll begin to do it in your head, and that speed will come once you've seen enough. You don't need to actually force yourself to be fast. I think that is one of the biggest mistakes I think people make when trying to improve. They think go, go, go. But what they don't see is that by removing steps like testing, design, and whatnot, and not spending enough time, it's akin to driving around without insurance. Yeah, you'll save a few bucks and maybe it adds up, but if you get ever hit in a car crash, you're going to wish that you had that insurance. So after solving, making sure that you record things in your practice diary, making sure that you have the right solution, and compare it to the book solution. This is why I recommend Elements of Programming Interview as the best interviewing resource. It allows you to see the step-by-step. The book does a fantastic job at laying out what the simple solution is and the naive solution. Simple solution, and then how they got to the optimal solution. And then being able to make sure that you can follow along. And then you can compare your steps with theirs, and then ask yourself if you were right or they were right, whether you were more efficient or they were, without sacrificing safety. Focus on this philosophy and two pieces of wisdom. One, this rules create discipline, discipline creates consistency, consistency creates habits, and habits create results. And the second piece of wisdom I want to impart upon you is from my personal hero, Charlie Munger. He is the vice president of Berkshire Hathaway, Warren Buffett's right-hand man. It is remarkable how much long-term advantage people like us have gotten by trying to be consistently not stupid instead of trying to be very intelligent. Focusing on deep simplicity works in many different aspects of life. And finance, whether it's finance or whether it's engineering. And these are generally recommended resources that I think people should read. I've found that only really 4 or 5 books are relevant to engineering. And once you've read those 5, you should branch out into other areas of life and take those lessons back with you to engineering. So that's my talk. Thank you very much for listening to me tell you about your 9 mistakes and why you may or may not be full of crap. I'll be happy to answer any questions from the crowd. I can see we already have a few. Okay, so I'll go through them pretty quickly. I'll see who stands out. Off topic, Edbert is a really dope name. Can we have the slides after this call? Yes, Raul will send those out. More stuff.
Actually, if it's helpful, Edbert, if it's helpful, but I can do that. I've been looking through. I can try and pick out a couple cogent questions that might be relevant to the audience. And
Yep.
then we can maybe do live questions as well. So one
I
that
can
came
stay.
in
I can stay
recently.
on for an additional 10 to 15 minutes. I'm not in a rush.
Okay, beautiful. So one that came in recently from Dan. Any tips for carrot style interviews where you're given like a technical phone screen without too much human interaction? Any thoughts on how to handle those?
Those tend to be very simple, and you really should be able to scope it out very, very quickly. I think if you go back to the slides, you'll see that I have a sample question, serialize and deserialize a general n array tree. There's really not too much scope that goes on in those questions. Like, it's pretty obvious what you need to do, and all you need to do is just do it. We very rarely are going to have a full on nuanced question. The reason why is because, between in-person interactions and the amount of time we have, that's just simply not possible. So chances are the question will come pre-baked to you.
Perfect. And then one more, and before we can do the live questions that I saw from a while ago. I think it was mistake number 2 or mistake number 4, not
Okay.
fixing your own mistakes. I think there was a question of that one. How do you know when you're making a mistake?
That's an interesting one. Like, how do you know when you're making a mistake? You really need to have another person or solution right next to you. I think that's the easiest way. So, for instance, if you're like, let's take a basketball analogy, right? If you're consistently failing to make 2-pointers, you're gonna wonder, am I hitting the maximum efficiency that I can? Well, if you're scoring Michael Jordan level points, like I think he had a record of like 54% shots made. Chances are that's the upper limit of what you can do. But if you find yourself like only hitting like 40% or 30% of your shots, then you might want to look at what Michael Jordan is doing. That's the easiest way I found to ask if you're making a mistake. Just look at other people, see if they're able to get things faster and better than you are. And if they are, then chances are there's something that you can learn from them and you are making some kind of mistake. Does that make sense?
Great. Okay, why don't we do some live questions? So just here, you can go ahead and unmute.
Okay.
Hi, thanks for your presentation, Edbert.
Mm-hmm.
Can you give me a referral for Uber?
No, I'm not gonna give referrals. That's a silly one. The reason why is because, and this is just a me thing, but I stake my reputation. Like I have a very, very strong feelings for my reputation. I really want to protect it, and so whenever I give a referral, it usually means I know this person is more likely than not to pass the interview, and I'm not gonna be wasting the company's time. And so I really only refer either past coworkers who I strongly believe in or my own clients.
Yeah, I like the
Okay,
boldness of it. Let's try and keep questions that are relevant to everyone in the audience. So if it's
I
only
have done 50 lead codes in the past 2 weeks, but okay,
Then you should be able to
thanks.
pass. You should be able to pass on your own merit.
yes. Okay, let's move on. Michael, go ahead.
So, hi, Edbert. Can you hear me fine?
Yes, I can hear
Yep.
you.
Okay, awesome. Thank you. Yeah, this was an incredible talk. I think it's just like a really great general problem solving talk. Um, and this is kind of maybe outside the purview of just tech interviews, but what other high value domains can these skills be readily transferred? Like, I see you as a really great coach. What other domains can I apply this to?
In general, you can apply it to really anything. So I've given numerous what's called examples of how it may apply to finance. In fact, if you look at the recommended resource, I think like half the books are finance related. So you might see stuff from Nassim Taleb, Victor Niederhofer. He was a great hedge fund manager in the 90s. Checklist Manifesto is actually a book by Atul Gawande, and he's a doctor. So what I'm describing here with using a checklist applies in multiple different fields. I think any field. If you want to know from me personally, I think it also applies to video games. And this is I used a very crude version of this approach and replay analysis when I was playing Dota, and I spent like 10,000 hours on that game, but I got up to like divine level, and that was like the top, I think, 5% of the player base. Of course, I didn't have the innate ability to do well in that type of game, but the idea still stands. If you can just eliminate mistakes day after day, go to bed a little bit wiser than when you woke up, you're going to do very well in any endeavor over the long run. So I think a lot of the principles that I'm talking about today don't just apply to engineering, they apply to any aspect of life.
Great, thanks.
Next question. Is there Wait, is that all the questions? I was expecting more. Whoa.
Yeah, well, okay,
So
so
I had
I
one,
have
but
question.
Okay, one at a time.
sorry, Edbert, I'll DM me my question just because I have an interview in 2 minutes.
Okay.
I won't have enough time. So
I have a question.
well, Preeti, go ahead. I think Preeti was had raised her hand, so Preeti, go ahead, and then Nicholas, good luck with your interview.
all right, thanks.
Thanks, Rahul. Thanks for the great talk, Edbert. What I wanted to ask, like the structure that you gave for the diary. So, for example, you're solving any problem. What advice would you give? Suppose if we are doing this like while we are practicing, like each question we are solving, how should we like come up with this time? Like because like currently, like suppose I'm solving, how would I just time myself like
You would just record.
parallelly?
You would just like literally just turn on the webcam and then just talk yourself out through the problem. And then just go back over the replay and then just put it on 2x speed, figure out what you're doing when. And that's how you do that's how you record your time.
Okay.
When you're in the middle of the interview, when you're middle of practicing, focus on executing. When you are done with it, when you're done with the problem, then beat yourself up.
Okay, got it. And second question, and what do you mean by serialize and deserialize? What did that mean in terms of, oh, that was a question, serialize and deserialize. Okay, I thought that it was a process you were doing.
No, it's a question that I love asking. Although I think the solution to it is maybe public. I don't use it for asking in interview questions. I think I have a different set of questions that I use, but yeah, that's a very good toy problem. I think it's almost always it's one of the more harder phone screen questions. I think you should try it out and see how well you.
And another question, Edward, could you please describe the process you go for your clients, like how you work with them?
Yeah. So the rough structure I do is I will spend 2 to 3 hours. I'll meet with them 3 times a week, right? And I usually live stream these sessions, at least in the past. I will spend 2 hours on the main session where it's later mock interviews, going back over the replay and point out, hey, you made XYZ mistake and kind of talking them through their mistakes. The second day we meet, it will be looking at any of the problems that they've done in practice and then sending me 1 or 2 replays. And the third time we meet will be 1 replay and then kind of doing a series of Q&A like, oh, I'm facing this difficulty, XYZ. Also, I ask them to keep a practice diary. I will grill them very, very hard if it's not detailed, if not being hard on themselves. And I'm there to not only keep them accountable, but also give them constant feedback as well. I also follow a similar structure to how one might train for the gym with progressive overload. We do a 6 weeks on, 1 week off cycle. And usually by the time the 7th week rolls around, we need only minor corrections before they go into the interview. And the reason why I do this particular step is so that way they don't burn out before they actually go do the interview. I think 6 weeks is probably the most amount of time that people can spend like giving up their personal life and severely focusing completely on interviews.
Okay. Thanks, Edward.
All right, Raghu, go ahead.
Terrific session. This is a question, it's a 2-part question. So the question is, how long do you, like when you work with a particular client, and in specific, someone who's probably more senior, like L5s and like L4 and above, what has been the observation of when they follow your pattern? How long does it take for them to succeed in interviews and like get into like the FANG level? Get a FANG level offer, or what have you seen? Some sort of metrics?
Yeah. So going back to the metrics, if I understand you correctly, I couldn't quite get it. You're asking if the time series changes if the client is a senior engineer or a junior engineer. I find that it doesn't. So there's like a few post interviews that I've done with past clients that have gotten staff offers and senior offers. The amount of time takes the same. It really doesn't matter, because it doesn't matter if you are a junior engineer or a senior engineer. The approach that I've described is going to be true no matter what your level is. All that matters is how more efficiently you are going to get at solving these problems. Now, of course, with the system design, there's going to be another angle at which we have to tackle, right? I'm not gonna have to only check that you're doing the data structure and algorithms correctly, but also the system design. But what I find is that most people at that level who are ready for senior and staff and above are more likely than not already have this engineering process innately in their head. So I don't need to repeat that to them. And so they actually do much better on the data structure and algorithms much faster, and they get to competency much quicker than, say, a junior engineer who's straight out of school. The system design is one that I find is a lot more difficult to convey. The reason why is because without having seen a complex adaptive system, you have no idea what you're really dealing with. I liken it to describing to a amateur player what playing in an NBA game is like. Yeah, you might see it on TV, but there are certain experiences that you aren't going to really fully understand until you're in them. And so I do my best to get them as close as possible. And I think if my hit rate is any indication, it shows that I'm pretty close. Maybe not perfect, but pretty close.
Awesome, great. One follow-up question I'll probably pause here. Have like usually for people who like your clients who are like more older and have like other family commitments and kids and stuff, and have a full-time job, how have they navigated this? Preparing for interviews along with balancing a full-time job, plus family commitments. I know there's a ton of advice out there, but what have you advised on how they can stay accountable and not fall off the tracks?
Yeah, that is a real problem. But what I found is that it's usually you don't usually have to give up too much. So let's say you put 40 hours a week in, right? And let's say you're someone who goes to the gym, 1 hour per day, right? That's already a third to a half of the time that you need to do to study for coding interviews, right? So I'm sure you could find 2 to 3 hours a day anywhere. It's pretty easy. I think if you're willing to give up on certain things. And you only really have to do it for 3 to 4 months, right? So maybe, okay, you spend a little bit less time with your family, but you could always make it up on weekends, right? There's 10-hour blocks, 12-hour blocks that you can just break up across the course of a day and just find that time. I think that if you really want to, you can find the time. But you really have to focus on only 2 things in your life that are priority. Maybe 3 if you're smart enough. But I find that most people can only focus on 1 or 2 things in their life and be actually competent at it. But more to the point, if you look at the whole point of my talk, what you do in the coding interview is what you're going to do in your career. And so you should be able to think of your career and the way you think about delivering code in it as practice for your coding interview as well, if you're doing it right. So.
All right, John.
Hi, yeah, great presentation. I love the document. Couple of just 2 questions. First of all, I find that a lot of the system design, basically almost all the system design references are flat. They're non-interactive. They're not giving me a chance to like practice. It's more like reading something being presented at me, and I'd like to turn that into something. I'm still struggling with how do I turn that into something that I can practice, like I can practice grokking or practice EPI. Second question is, do you see any improvement coming in the hire rates? Like I saw the 40% for your clients in 2022. Do you feel as though the market is starting to get any better at all, or are we still in the doldrums of the last year or so?
Oh, okay. So let me handle each one. The first one, you're basically asking how can you improve using existing resources? I think I outlined in my document that you can use grok in the system design and do the exact same technique that you would use for a data structure and algorithm, that you just look through the solution that they give, look through the solution that you give, and go step by step why you decide to give the solution. Now, the shortcoming of grokking is that they only really give very flat reasoning. They don't show the chain of iteration or the chain of of why certain trade-offs were made. They do like a very static back of the envelope stuff, et cetera, and just kind of give a reason, but not the evolution of that reason. And so that makes studying system design pretty difficult. And I think you're kind of on your own a little bit for that one. Of course, that's where I come in, and that's where I think I'm the most effective. I constantly give like a lot feedback on the thinking and making sure that it is actually logical, consistent, and reasonable. Sometimes we'll talk about existing blog posts like from Facebook or Google. Everyone says read blog posts. I think that is a little bit difficult because, again, going back to the basketball thing, it's like writing write-ups on a basketball game, but these are written by sports journalists, not necessarily people who have ever played a game, and so the perspective will be completely wrong. Or they might be written by someone who has actually played the game, like Shaq, right? But the commentary might be so nuanced and layered that they go over people's heads. So I don't find engineering blogs, unless you've actually worked on those systems yourself, to be of really much help. And so it's a complex question, right? I don't really have a good answer, but this is the best answer that I've found right now. I think if you understand complex adaptive systems and their nature and combine it with the information you're given, then you should be able to do quite well. The second question that you asked me was about macroeconomic environment and hiring. I do see some opportunities opening up. In fact, some of my current clients that I'm working with have actually passed the Meta phone screen, but Meta, to my knowledge, is hiring only at the L4 to L6 level, but it's across the board. So yeah, recently one of my clients has passed the phone screen. Like I've handed him his information like a week ago, and now he's going to go to the on-site. And this is a guy who actually, and this is not shown in the statistic, he actually passed Google last year in 2022, but didn't get hired because they were culling headcount. So even though most people might report that number as a win, I report it as a loss and a failure because we didn't get the job offer. I try to be very, very honest, brutal, and strict with myself. I don't give myself any wiggle room for these kinds of numbers. So I know he can pass Google, and so I'm very, very confident he's going to do well at the Meta interviews.